Okay, so this is Lab 7, and today we're going to introduce some new concepts for modeling manufacturing systems. And specifically, we're going to be focusing on the arrival processes for our system. So far we have been modeling this arrival process using a probability distribution, which assumes that that arrival process is not going to change throughout the day. And that could be the case for some systems, specifically for systems in which you have a steady, I would say steady demand. But there are other type of systems in which that's not the case. So for example, you can have systems in which you're gonna, like for instance, a bank or a hospital, or it could be a restaurant in which you're going to have certain periods of the day in which your demand is going to go up, and then it will go down, and then will go up. And there's going to be a pattern for that demand. But again, you will see that the pattern is showing up a increase and decrease in demand according to the times. So for those purposes, we can use a different way to represent that changes in the demand for the arrivals of your system. And that's what we're going to do today. We're going to introduce the use of schedules for the arrival processes, which will allow us to basically change the average demand or the average arrival number of arrivals that we are seeing in our system according to the times of the day. Okay? So that will be the focus for today's lab. And again, I'm adding to the slides that we've been discussing through the semester. So, and very important thing that I always highlight is the difference between an attribute and a variable. Still see people having issues in terms of differentiate between them. So in the assign block, you will have the option to assign either an attribute or a variable. You need to make sure that you're using the right one, because if not, the model itself will be wrong. So the attribute is something that is not going to change. It's a property of the entity. And a variable is information representing some characteristic of the system, which will change according to the processes that are involved in the system. Okay, so remember to save your model. Make sure that you always keep a copy of it. Um, Let me go straight to the new things. So today we are going to be dealing with some of the logic inside the create block. So this is most of the things that you use to initiate your model. And as you can see from this slide, if you open that module, you'll have an option in terms of deciding what type of arrival you're going to see. So in this type, there's going to be an option for you to say that you want to use a schedule instead of a distribution to represent your arrival process. Okay, so we're going to use this new type today. Other than that, most of the things that you have used will be represented as well in the exam, in the example, and in the exercise that you have to complete after our discussion. But let me go straight to the new material for today. So here we are. So today we're going to be focusing on using these schedules. And again, the focus for today is going to be the arrival process. But you can also use the schedules to represent the status of your resource throughout the day. That's going to be a discussion for next time. But that's the other capability of this logic. So focusing on the arrivals, The schedules are under the basic process module in Arena, and it will show up as one of the spreadsheet icons inside this module, basic process module. It allows you to define an arrival rate based on the daily time or calendar, and the entities will arrive according to this schedule. Okay, so if you have a demand for the day, let's say that you were saying, let's say you start your day at 8 o'clock, and you enter you're running the restaurant from 8 to 8. So most likely, if you serve breakfast, you'll see some demand in the morning, but then as the day goes, there will be, this is the number of arrivals. As the day goes, let's say this is 10 a.m., so at 11, then at 12, probably you're going to see an increase in your demand in terms of the number of arrivals. And then probably your demand will go down again until you get to 5, probably, when you're going to see more people coming in, and probably they will resume towards the end of the day. So again, the purpose of this project that we're going to use today is to be able to capture those fluctuations throughout the day. So we're going to focus on how to model these fluctuations in terms of the arrivals. So we are not longer assuming that we're going to have the same average arrival rate throughout the day. We're going to have different arrival rates according to the demand of the system. So the focus for today is going to be the entities, the arrivals, but as I mentioned already, we can use these logic as well to define the availability of the resources throughout the day. But that's going to be material for the next exercise or the next method. Okay, so in terms of the parameters, the name that you use to the schedule is important because that's what you're going to be using to call it inside the create block. So we're going to give a name to that schedule, and we're going to specify a type. So we're going to use the duration type. How the schedule will be defined. And we also have to define the type of schedule. So today we're going to focus on the arrival schedule. And the arrival basically will define the arrival rate of the entity. That's basically needed. So if it's changing, you're going to be able to decide how many are we, or what is the average number of customers in each community that we are expecting throughout the day with this system. You can also specify time units. The scale factor basically modifies the schedule by scale. For example, the arrival rate times that scale factor will give you the true arrival rate. And that is used sometimes when you are doing experimentation. So if you want to see what would happen if the delivery size is then you can use that scale factor to represent that. And then the duration button that allows for graphical readability, and we're going to use that today. Okay, so here's how are we going to do this. The Arena software will provide you with this screen, and you're going to define the start of the day and the end of the day for your system. So usually the 24-hour period is what we use to define a day. And then on these aces right here, you're going to define the average arrival rate that you're expecting in your system. So obviously you can define this in terms of hours, minutes, depending on how you have that arrival rate defined in terms of the time units, and you have to represent that here as well. So Arena will give you the option to read the schedule in hours, days, minutes, so you have that flexibility. In this case, we have the day in hours. So our arrival rate will be defined in terms of the arrivals that you will see in the system per hour. So every column here represents a different hour. Okay? So for this specific case, what we are saying is at the beginning of the day, so we are assuming that we have a 24-hour hospital or 24-hour store that is open the whole day. And here, this is saying that at 12 a.m., you're expecting an average two customers or two patients. And that will be the same if you get to 6 a.m. So at 6 a.m., you expect that arrival to change from two arrivals on average to four per hour. And then at 8 o'clock, that will go up to 8 arrivals per hour on average, and that will be the same until the end of the day. So that's what this schedule is showing. Okay, so again, this will have a lot of options. If we click on this button, which I will do with the example, you will see all the options that you have to make this window adaptable to your problem. Okay, and once you have defined your schedule, then you can go to the create log and specify, instead of a probability distribution, you're going to specify that you're going to use a schedule to represent the arrival process of your system. Okay, so you're going to have to put that as your type and then find the schedule name that you use for your model. Any questions? So it's very simple, but it's very powerful in terms of modeling certain type of systems, especially for those in which you have a 24-hour system that is open 24 hours and you want to represent what's happening throughout the day. So you're familiar with this section of the lecture, so I think I'm going to go straight to the example that I prepared for today. So here's the example. We're going to model a store that is open 24 hours. And what basically we have here is that you're going to have a non-stationary arrival process that is going to be changing throughout the day. And the customer will arrive to the store, will spend certain time in the store, wondering, finding out what they're going to buy, and that is represented by this gamma distribution. And then after they're done searching for the item, they'll go to a cashier station, in which they're going to wait on a single queue, and they're going to pay for what they're buying. So we're going to have two types of customers. 50% are type A, it will take 2 minutes to pay. Those are the ones that pay with credit card. And then we have half of the customers that will take 5 minutes. Those are the ones that are coming with coupons and paying with cash and so on. Okay? So the other thing that is important here is that we're going to have a different, again, non-stationary arrival process. So we expect 4 arrivals per hour from 12 a.m. to 10 a.m. and then 10 arrivals per hour from 10 a.m. to 6 p.m. and then 8 arrivals per hour for the rest of the day. And we are interested in computing the mean number of customers in the system, so this is the working process. Actually, today we're going to also focus on what if you want to know how many customers are in the store at a specific time of the day. So I want to know how many customers are in the store, let's say at 5 o'clock. That's something that we can also do with Arena. So in this case, I want to know what is the where at 6 p.m. And then what is the average cycle time for your customer. You can use 10 replications and 10 days per replication. And we're going to also choose a priority to it. So we're going to give a priority to the shortest time first. So that will be here. So we want to take care of the customers that are going to take less time first. Okay, so I'm going to show you how to do that as well. So let's go to the software. need to find my templates. Okay, so I'm going to start by saving this. So this is sample 7. Okay, so let's start by defining the schedule. Okay, so we can go to basic process and you'll see the schedule option here. So you can click there. And that will open this Go window here. You can double click there to add a new schedule. And we're going to give a name to this schedule. So in this case, I'm going to call it arrival schedule. And the type for this case, instead of capacity will be used to model the availability of resources. But today we are not interested in modeling the capacity of resources. We are interested in modeling the arrival process. So this is going to be arrival. You can specify the time units. So if you have the arrival in terms of minutes or you have the arrival in terms of hours, you can change that here. Let's see. Seconds, minutes, quarter hours, half hours, days, you have multiple options. Okay, and the scale factor, see, I'm not making any changes so far. I'm going to keep the same arrival rate. I'm not changing this for this case. But then I'm going to go to the durations. I'm going to click here where it says 0 rows, and you will see that window that we talked about earlier today. Okay, so from here I want to show you something first. If you go down, there's a button here that says options. If you click there, that will allow you to edit your window as you need for your system. So right now, we have time slots that are defined in terms of minutes, of hours, but again, if you change that to half hours and then click apply, you'll see that now you have some extra columns. So here is the first hour is divided into 2, the second hour is divided into 2, so you have the capacity of changing that in terms of half hours. That would also apply when you have minutes. So you see now the first 5 minutes, the next 10 minutes. So, and then if you need to move down there, you can go up here. You have that arrow that will move your calendar forward. But as you would expect, the smaller the time interval, the more editing you have to perform into your window. So, so most of the time you'll see that we're gonna define the arrival in terms of hours, probably half an hour is also doable, but go to the minute case will be very difficult, especially if you're doing a 24-hour day. So I'm gonna keep this as an hour. Also, you can specify the maximum number of arrivals that you're expecting. So right now is 10. So that's why you see these 10 here in this corner. So the y-axis will go up to 10. But if you change this, for example, to 25, click apply, you will see that changing to 25. Okay, so you have to understand what is the maximum number that you're expecting to set up this y-axis. And then let me put this back to 10. The minimum is 0. Snap spacing, I'm not pretty sure what this does, but it's not relevant for the modeling. Okay, so I'm going to apply this, and then I'm going to start editing my schedule. Okay, something that you need to be aware of is what are you using to specify the beginning of the day. So if you use 12 a.m. to specify the beginning of the day, you have to keep that in mind when you are trying to build your model, because you have to keep that number as consistent as possible, especially when you are defining your statistics. So if I use 12 a.m. right now to specify the beginning of the day, when I'm computing the statistic of what is the web at 6 p.m., I need to be aware of my starting time. Okay, now, and we will cover that also today. But for now, I'm using 12 a.m. at the beginning of the day. So I'm going to specify this arrival process for as stated here. So we have for an hour from 12 to 10 a.m. Then 10, an hour from 10 a.m. to 6 p.m. And then 8 an hour from 6 p.m. to 12 p.m. So if I go here from 12 to 10 a.m., we have 4. So I can click here, 4, 4. Okay, so that's up to 10 a.m. So 2 hours after 8. And then from 10 a.m. to 6 p.m. is 10 an hour. So go up to here. So that is 10. So this will be 11, 12, 1, 2, 3, 4, 5, 6. And from 6 p.m. to 12 a.m. I have 8. So for the rest of the day, we'll have 8. And that will cover this particular schedule. So it's kind of, yeah, you have to be cautious in terms of making sure that you are selecting the right height. So 10, 8, and 4. Questions? Okay, so once this is done, you can click OK. You have your schedule defined. So once we start defining our arrival process now, using this create block, I can define my arrival process using a schedule. Okay, so you open this create block, you can define your arrival type using a schedule. Then you're going to find the schedule name, which is the arrival schedule. And the entities per arrival is one at a time. maximum arrivals is limited. So you don't put in, we're not putting in a limit in terms of the arrivals for the system. Um, so after that, we can click OK. And then the rest of the model is just repetition of what we have done. So I'm still gonna guide you through the process. So that completes the new thing that we were explaining today. For the rest of the model, let's go back to this. So we are going to use an assign block to assign the arrival time. So let me put that here. So I'm going to add an attribute that is called arrival time, and the value for that attribute will be t now. And I'm also adding a variable that I'm going to call width, and the value for that is width plus 1. So the first one is an attribute, the second one is a variable. Any questions? Okay, so after that, I'm ready to split my entities into two groups. So we know 50% of them will go to one branch, the other 50% will go to the next branch. Or actually, just, thank you. So I'm going to use this branch to assign the processing time. So I'm going to have one assign block for true and one assign block for false. So this assign block basically is going to split the entities. 50% will go through one branch, the other half will go through the other branch. And I'm using this to represent the time that it's going to take for them to be served at the cashier station. So 2 minutes for type A, 5 minutes to pay for the other one. So this is going to be also an attribute, and pay time. So for this group is going to be 2 minutes. And then for the other one, I'm going to add here. It's going to be also an attribute. It's going to be the same attribute, pay time, and for this one is 5 minutes. Okay, any questions? Okay, so from here I can just go to model the delay time and also the processing time for the cashier. So I'm going to have a delay block and both of them will go to that delay block, and it's gonna be using a gamma 5.4. So I'm gonna open this delay time, use a gamma with beta equals 5 and alpha equal 4, and this is a minute. Yes. 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 There's two delays on this system. One is for the time that they're going to spend searching for what they want to buy, and that is represented using the gamma. And then there's another delay for the cashier. So that delay that you're talking to about is the one that we're going to use now for the cashier process. Okay? So you're right. We're going to use that one, but for modeling the time to pay at the cashier station. The delay that we just inserted into the simulation is just for representing the time that they're spending searching for the items that they're going to buy. Okay? So, good question. So after specifying this delay, which is going to be modeled the same for both of the customers, now we're going to add a process block to represent the cashier station. So for this one, we're going to double click and we're going to use a cease delay release. And I'm going to call this a cashier. And then the delay type is going to be an expression in minutes. And the expression is going to be the attribute pay time, which is what you were referring to. Okay? And then from here, we just have to collect the statistics. So we need an assign block to decrease the width. So I'm going to call this width -1. So it's still a variable width, and I'm going to decrease the value of that width by 1. You can just raise your hand if you have any comments, questions. I don't want to go further if you're not with me, so just let me know. Okay, so I'm gonna click OK, and I'm going to connect these to the process and the assign block. And what are the statistics that we want to collect? Well, we want the mean number of customers in the system, and also the same statistic at some point in the day, and then the average cycle time. So I'm going to use a record block to collect the WIP, and this is going to be the uh, number in system. And what else? And we have another record block, and that WIP that we are collecting here is going to be the WIP at the end of the 10 days. Okay, so since we are running this experiment for 10 days, that number would not be as useful as we would like to, because basically we're waiting until the end of the 10-day replication to get that number. So okay, we can have that information, but it's not very useful. And that's why we want to point out specifically at what time of the day we are interested in knowing the working process. And that logic we'll define in a second. But that's the reason we are doing that specific question, specific for this type of system that you're running for multiple days. But before we get into that, let's define the cycle time. So this is going to be a time iterable, and the attribute name will be, arrival time, and this is cycle time. And after that, we can add our dispose block. It'd be a good idea to check the model just to make errors so far. Still have a couple of things that we need to address. So for now, please let me know if you're doing fine. If you have any errors, let me know. Yes. Let me stop the. We can also try to define some of the statistics at this point. So let me go to statistics, the advanced process. So I want to generate a output for cycle time. So this is going to be a tally cycle time. and the report label will be AVG cycle time, or the average cycle time for the system. And then I also want to define the width. So the width is going to be time persistent. So width in system. And I'm going to add an output for that, the AVG width in system. This is AVG width in system. Okay. We can also set up the experiment. So it's going to be 10 replications. Replication length is 10 days. 24 hours a day, and the base time units are minutes. Okay, so 10 replications, replication length is 10 days, 24 hours per day, and the base time units are minutes. To apply the report, you'll always use the Simon summary report. And then the project parameters, you uncheck them all. Okay, so let's run this. Yeah, I forgot to take the animation out. Okay, so we have the weapon, counter weapon system, and again, this is going to be at the end of the 10-day replication. So after 10 days, this is the number that I'm having at the end of the day in my system. And then I have also the average cycle time, which is saying that customers spend about 25 minutes in the system after searching for what they're going to buy, and also after paying. But there are two things that we need to include in this model. The first one is how are we going to compute the WIP at 6 o'clock? And the other one is how are we going to prioritize the customers that are in the queue, the customers that take less time. Okay, so those two things are still pending. So let's deal with the first one, the statistic. So as we did for one of our labs already, I'm going to include a separate logic to collect this number. Okay, so I'm going to use a different or a separate logic to be able to collect the WIP at a specific time of the day. So I'm going to use a create block. I'm going to use a record block, and also a dispose block. And in this create block, I want to generate an entity at a constant time. So remember, we are going to have 10 days in this replication. So I want to be able to collect the weight at 6 o'clock for each one of them. Okay, so for this, I want to generate an entity every 24 hours, but I want my first creation to happen at 6 o'clock. So I need to put a number here that represents 6 o'clock in my system. And this is what I was talking about at the beginning, saying that this will depend on what you define at the beginning of the day. So right now we define our schedule saying that 12 a.m. is the beginning of our day. So if I need to specify 6 o'clock here for my first creation, it has to be this many hours after 12 a.m. And that number I believe is 18, right? 18 hours after 12 a.m. So that's the number that I want to put here. What's going to happen is my first creation is going to happen at 18 hours. And then I'm going to generate an entity 24 hours later. So the next day at the same day, the next day at the same time, I'm going to generate another entity. The next day at the same time, I'm going to generate another entity. So at the end of this replication, I'm going to have 10 values for the web, all of them representing what happened each day at 6 o'clock. Okay, so this is the logic that we're going to use. And I'm going to record this as an expression. The value is going to be the web, and the tally name that I'm going to use is web in system, and then 6 p.m. So you're following what I'm trying to do, right? I want to get this number at 6 o'clock every day. We have 10 days for replication. So I'm creating this separate logic to gather that information at the same time every day. So I'm going to click OK, and then I have to define this in my statistics. So I'm going to go back here, statistics. So I'm going to define another time persistent. It's going to be also width. Wait. Okay, so something that I need to clarify now. Now the way that we are going to define this is different. It's no longer the way at the end of the day. What we are doing is we are gathering data at 6 p.m. So basically what's happening is at the end of, at that time of the day, we're going to put a number into a bag. And then this is the first day. The second day, we're going to add another number. Third day, we're going to add another number. So basically what we're creating is what we want to report is the average of those 10 observations. Okay? So the way that we are going to generate this output is by defining a tally, an output of a tally, TAVT, within system 6 p.m. And this is going to be AVG within system 6 p.m. Let me double check this. Yes. So if you run your model now, you'll notice that there's a difference between the width. It's a bit higher than the width at the end of the day. And we go back to the schedule of our system. Yeah, 60 and the levels are higher. So that's why you're noticing there's a difference toward the end of the day and this one. Another point that I want you to do is how are you going to give a priority to the charges time first? And before we get to that, let me show you with an animation what's going on. Okay, so you're going to be learning something else today. So I'm going to change this. I want to keep the animation now. And basically what I'm going to do is to add a entity picture to each one of these entities. So I want this first to be a blue ball. So a picture, I'm going to use a picture of a blue ball to show, or maybe I can use women and men. That will be more close to what we're trying to represent here, which are customers. So I have a man for first group, and then for the second group, I'm going to add a picture, entity picture, and it's going to be a women. Okay? So if I run my simulation now, most of them are going through the first branch. So we have, okay. So you see now, when they go to this branch, it shows a man. When you go to this branch, it goes to show a women. Okay, so that's what I wanted to represent that. Um, but I need to make sure that I'm generating a queue, and that queue is not happening right now. So you have a person in queue, another person in queue now. Both of them are men. So let me see what happens if I increase. So I'm going to use that scale factor right for a second. Just want to illustrate a point. So I'm going back to here, and I'm multiplying. I want to increase my demand. I want to show a queue happening in the system. So I'm going to make this 10. See what happens. Okay. Okay, so that's what I wanted to show up. So you see now have both men and women forming the line. Okay? What you want to see now, remember which one of them had short period of time. But what I want to see now in the queue, when we implement the logic of starting the person with the shortest time first, is that you just start seeing split between some entities and people. You will not see them split. You will see one group on one side and one group on the other side. So when you want to implement a logic like that one, and I think men are going to be first because the duration is 2 minutes. Um, so for that, what you're going to do, that will be related to the queue of your system. So if you click on that module in the queue, you have the type of queue that you want to, you have several options in terms of deciding what type of queue you want to have. In this case, I want to use the lowest attribute value, because I want to choose the person that has the lowest process time first. So I'm going to choose that to lowest attribute value, and the software is going to ask you which attribute. Okay, so I'm going to find pay time at the end of the list. And by implementing this, now I can see that splitting. I want to see the minute first and then the because they're going to take less time first. So let's see if that happens now. You see now we have all the women waiting. Because we are giving priority to the men, right? Because they're going to take less time. Okay, so those are some systems I would say not necessarily on the floor, you will not see that happening. But in manufacturing, probably you want to take care of those that are going to take that time first and then use time the rest of the time. Sometimes, sorry, in healthcare, you will see something like that happening. If you can serve multiple patients first, you will take care of those, and then you're going to spend more time on those that are more critical. So there's a lot of systems in which this logic will make sense. So that basically concludes our discussion for today. I don't know if you have any questions. Yes. Yes, I can take a look. Let me stop the video.